Hello, geometry students. We're going to start algebraic proofs, and this is just an introduction to proofs in this class, and we're going to use properties of equality to do so. So what is an algebraic proof? It's a proof that is made up of a series of algebraic statements with properties of equality providing justification, and that's the big part here. We are justifying what we're doing. And that's just all a proof is. It's just saying, why did you just do the step that you did? What's your reasoning behind it? So here's the properties of equality. I'm guessing, I think this might be in your packets, hopefully. So if it's not, then write it in your notebook. So pause the video and write this down. When you unpause it, we're going to go over some examples. So the subtraction property, if A equals B, then A minus C equals B minus C. So if we had like 8 equals 8, if I were to subtract 3 from both sides, then I could do that. And I would get 8 minus 3 equals 8 minus 3, so it equals 5. Same thing with the multiplication property. If I have both sides of the equation, I can multiply. Let's see, if I had 2 and 2, if I wanted to multiply both sides by 3, that would be the same thing. But I have to multiply both sides. In division property, if A equals B and C does not equal 0, there should be a slash to that, that's a typo, then A over C equals B over C. So like if we had 4x equals 4x, we could divide by 4 on both sides, like so. And it doesn't even have to be the same on each side. I could say 4x equal, we could say 16, as long as I'm dividing by 4 on both sides. Reflexive property, both sides of the equation are the same, so we could get x equals x. Symmetric property, if you're going to switch sides, so if we had 4 equals x, it's the same as x equals 4. Transitive property, if A equals B and B equals C, then A equals C. If we had, for example, like if a triangle equals circle and circle equals square, then we could say triangle equals square, something like that. Substitution property, if A equals B, then A may be replaced by B in an expression or equation. So you might see this like after we do the distributive property, if we have like 4 times negative 5, we could substitute it with a negative 20, for example. And the distributive property, if we had 3 times x plus 2, we could write it as 3 times x plus 3 times 2. Then we could write this as 6 using the substitution property. And one property that's not on here is the addition property. Very similar to the subtraction property. If A equals B, then A plus C equals B plus C. So you might want to add that on there. So if I had 3 equals 3 and I wanted to add 2 here, it would be the same thing. So this is how an algebraic proof works. We're going to solve this equation to prove that the answer is x equals a negative 18. And that's all we're going to do is we're just going to solve it over here, and then we're going to put our reasons here. So this is really good for just writing down every single step. We can't skip any steps. So for example, we're first going to write down negative 5 x plus 4 times the quantity x plus 4 equals 70. And that's given to us. So we're going to write that down. We're going to write given. Now what would you do next? Think about what you would do next. Right, you would probably do the distributive property. So we have a negative 5 times x plus a negative 5 times 4 equals 70. and that is the distributive property. Of equality. I know this gets kind of long here, but we'll just write of equality like that. So then what would you do to solve for x? Right, I would make this a negative 20. So a negative 5x plus a negative 20 equals 70. And what did we just do there? We substituted this, negative 20, in for this. So that's the substitution property. Lots of writing. Now what would we do? Well, we have plus a negative 20, so that's the same as minusing 20, so we would add 20 to both sides, right? So we would add 20 to both sides, and that would be the addition property of equality. And so then we're going to go ahead and substitute again. Negative 5x equals 90, so that's the substitution property. And how would we divide now? Or we would divide now by negative 5. So that is the division property. And then our last step would be 90 divided by negative 5. We're going to go ahead and use the substitution property. Now, this is what the book shows you. And the book shows the substitution property quite a bit. Now, that is a teacher preference. Now, this is the way the book does it. I'm not a big fan of the substitution property, doing all that or writing that down every other step. And so that will be, again, Mr. Card's preference, what he wants you to do. I would just say distributive property and then actually just write this next step. And so it'll look like that. And I can do another example where the substitution property is not there. Okay. So again, that's a teacher preference. So yeah, that's how you write an algebraic proof, pretty much. Not too bad, huh? All right, and we'll see y'all later. Come with questions.